Okay, so I'd like to hand over now to Mark Del Campo, who's one of our application scientists from the American side of the organization. So Mark, I'll let you take it at your leisure, and thank you for the presentation in advance.
Hi, thanks Fraser for the introduction. I'd like to just welcome everybody to the webinar. Today I'm going to talk to you about our new Actor 2 sample changer for automating your single crystal workflow. So just an overview on the Actor series, and let me just turn my camera off so you don't have to look at me the whole time. There we go. So an overview of the Actor series. Actor is actually an acronym. It stands for Automated Crystal Transport, Orientation, and Retrieval. It's a high capacity automatic sample changer. You can put up to 112 samples in the Actor Dewar, and it can operate with up to 3 dewars, which is a situation that happens at the synchrotron. We have more than 70 Actor installations worldwide, and the product is just over 20 years old, so it's a mature product. The Actor system can be used with our Crystal Lab Synergy Custom line of products, which is shown on the picture at the right. So just to go over the components of the Actor 2 system, basically you have a robot arm, a dewar, a dryer, an automatic goniometer head, a pin detection mechanism, and of course, you need software to run all of the hardware. So let's start with each component one by one. So let's start with the robot arm. So the Actor 2 system features the new Universal Robotics UR5 6-axis robot arm, which is shown at the right. And every robot arm has a functional bit, which is on the end, and this is the end effector. So we have our Generation 4 end effector. It grips the sample pin like cryo-tongs, and it is stable in liquid nitrogen for up to 24 hours. And we also have a new touchscreen teaching pendant that comes along with this robot. The next component is the dewar. So inside the dewar, which holds all of your crystals, the base plate is what defines what kind of pucks go into the dewar. So we are compatible with Unipuck, ALS pucks, ESRF pucks, and Rigaku pucks, depending on the base plate that you get with your Actor Dewar. If you choose Unipucks, which is what most people are using now, you can put up to 7 Unipucks inside the dewar for a capacity of 112 crystals. The dewar features a heated rim and a heated sliding lid to prevent ice buildup, and it also comes with an autofill solenoid and a liquid nitrogen level monitor. A dry dewar fills with the autofill system in about 10 minutes. A dryer is also a necessary component. So when the end effector comes out of liquid nitrogen, it will be cold and the room air will condense onto the outside of the end effector, causing ice buildup. And so it's necessary to warm up the end effector in between mounts or at the end of a run. And so the dryer is a critical component. So our standard hot air dryer can dry the end effector in about 90 seconds. And we also have an option for a higher speed dryer that can dry it in 22 seconds. The automatic goniometer head is another component of the system. It's critical for being able to auto center your crystals once they are mounted. And so this is using our new intelligent goniometer head, or IGH, which is pictured there on the right side. So it's automatic XYZ centering. It's designed for a minimal collision profile with our universal goniometer. And it has a built-in magnetic base for using spine or ALS mounts. And with the Actor system, you can also use copper pin mounts as well. Pin detection is important so that you know where your pins are on the system and that you don't have any collisions. So as far as pin detection goes, we have a contact pin check inside the dewar. So I'm going to show you here with my mouse. There's this post on the base plate where the Actor can do a contact check to see if it's picked up a pin. And there's also a laser which points at the goniometer position at the IGH to detect pins when they're on the IGH. And then lastly, there's actually a third component, is that the software, CrysAlisPro, actually checks the crystal viewing camera to see if it can see anything on the camera that looks like a sample mount, and that's the third check. Finally, to run all of this brilliant hardware, you need brilliant software. So we're using CrysAlisPro and its new CAP Robotics module to control all of the hardware and give you a seamless interface if you're used to using our other instruments. And we also have a new cameraman control program that is talking directly to the robot and interfaces from CrysAlisPro to the robot. So now what I'd like to do is take you into the lab and give you an Actor 2 demo. Here's the Actor 2 system set up on the right port of the FRX rotating anode X-ray generator. The Actor 2 features the UR5 6-axis robot arm. It's equipped with our 4th generation end effector, which can stay submerged in liquid nitrogen because there's a heater on the inside. In between samples or at the end of a run, you can dry the end effector and warm it back to room temperature using this dryer. The Dewar plug sits on a post here, and it's detected by the system when the plug is at the post. Here's the Actor 2 Dewar. It has a heater in the rim and in the sliding lid. Let's take a look inside. There's a fill port here, a liquid level sensor, and a pin checking post. The base plate that you see here on the bottom can hold 7 unipucks. On the universal goniometer, we have the intelligent goniometer head, or IGH, and we also have a laser which detects pins at the IGH position. The first step to using the Actor 2 system would be to prepare some flash-cooled crystals in a magazine or a puck. Here I'm sitting at the microscope looking at a tray of lysozyme crystals. I select one of the drops, flip over the cover slip, and look at it under the microscope. I put a pin and loop on the end of a magnetic wand and go fishing for a crystal. When I find the appropriate size lysozyme crystal, I'll get it on the end of the nylon loop and then immediately plunge it into liquid nitrogen. Then I transfer the crystal to a cryo-tongs and then move it into a secondary dewar containing the unipuck. That's 1 crystal down and 15 to go. Once all the crystals have been placed in the puck, the only thing left to do is assemble the puck completely and transfer it into the Actor 2 dewar. Here I'm using some specialized cryo tools to manipulate the lid of the puck and get it firmly seated. Then I flip the puck over so that I can insert the puck loading tool. And now I'm ready to load the Actor 2 dewar. To load the dewar, I will remove the Actor 2 dewar plug and place it at the post, and then remove the Actor 2 dewar lid. Then I will use the puck loading tool to place this unipuck right in position 1. I will seat it firmly by giving it a little wiggle, and then I'll use the plunger on the tool to separate the puck and leave the pins under liquid nitrogen in the dewar. I will replace the Actor 2 dewar lid, but to replace the dewar plug and have it in the proper position, I need to use the hardware. And I'll move the hardware via CrysAlisPro by clicking on the Robotics tab, and then on the Interact button. And then in the dialog, I will select the Close Dewar radio button and click on Start Action. And the robot will pick up the plug and put it on the Actor 2 dewar lid, centering the lid in the process. Next, I need to tell CrysAlisPro where the samples are located. I click on Plan Modify and then on Inventory. This is a graphical display of the pucks inside the dewar. I have to make this display match the reality of what's inside the dewar. I can select all of a puck by clicking on the puck's name and then click Remove Puck to remove it. So I've removed all of puck 1. Now I'll click it again to select all the positions, and then I'll click on Filled to designate them as all filled. Any single position can be edited by clicking on it and then clicking on Edit Sample Information. In the dialog, you can enter a sample name and a comment and a formula if it's a small molecule, and when you're finished, click OK. And then when you mouse over it, you can see the name that you entered. In this particular case, what I want to do is select all the samples in the puck by clicking on the puck's name and then clicking on Edit Sample Information. And now I'm in the multi-mode editor where I can give all of these samples the same name, which I'll call them lysozyme. And then I'll click on the centering options, Apply to All, Edit, and I'll change the centering options. So we're using crystal centering via CrysAlisPro. First, it'll center on the loop, and I'm just changing this loop length to 300. And the type of mount is immersed in oil or liquid. It'll help the crystal finding algorithm. Click OK, and then click OK again. Then when I mouse over any one of these samples, you can see that the sample name and the centering settings were taken. At the end, you just click on OK to exit. Now I'm ready to create a job in the Robotics Jobs Planner. I click on Add. I will select myself from the user list and click on Set User to open up the Robotics Task Editor. The first task is to select the directory where I want to put the data, which is already selected, and then I'll name the job. In this case, I'll just call this Lysozyme Screen and Rank because that's what I'm going to do. Below the job's name, I have to select all the pins that are going to be in the job, so click on Select Pins, and then in the graphical display, I'll click on the puck and click OK, and then all the pins from puck 1 show up in the list. Then I'll select Protein, and I'll pick the screening options that I like to use. In this case, an exact distance of 41 millimeters, a resolution of 1.7 angstroms, a rotation width of 0.2 degrees, and an exposure time of 4 seconds. In addition, I will turn on the compute ranking score. So under ranking rules, you can see that this is a system for giving you points and giving you penalties for certain features of your diffraction data, like finding spots, resolution, what the spot shape looks like, whether you have overlapping reflections, and whether you have ice. So all of these things have defaults, and you'll get a numerical value which will tell you something about the quality of the screening. In addition, besides just doing screening, you can do data collection also. But you have to apply a condition. In this case, no condition would mean you get a data set for every crystal screened. But if we apply the condition of minimum ranking score, we can set a threshold for a rank score you'd have to have in order to get a data set. In this case, I'm only interested in doing the screen and rank, so I'll turn data collection off and then click OK. To start the job, I'll click on the job in the list to give it a check mark, and then click on the Start button. Simultaneously, when I click Start, I'm going to start a timer so we can follow the progress of screening puck number 1. Now, the first thing the robot's going to do is remove the Dewar plug and put it at the post, and then the robot will place the end effector inside the actor Dewar to cool the tip down to liquid nitrogen temperatures for safe transport of the cryo-cooled sample. This cooling operation is called a soak. It usually takes about 1 minute, 10 seconds with the settings that I have on the system right now. And that means we have a little bit more time before the soak is complete. So let me point out a few other things. The large camera view you see on the right-hand side is a camera inside the instrument bay that shows you the whole setup of the system. There's a small camera mounted on top of the goniometer, circled in red, and that provides the camera view that you see on the left. This camera view is plugged into the cameraman piece of software. Its sole purpose is to record the mounts and the dismounts to the IGH so that they can be used for troubleshooting purposes afterwards. And Cameraman even supports multiple cameras. So if you want to have multiple viewpoints of the system and have those views recorded during mounts and dismounts, you can plug those in. We're nearing the end of the soak now, and as soon as we reach it, the robot will start to move again, and go find pin number 1. There it goes. It'll pick up pin number 1 and then come out of the Dewar and mount it on the IGH. Sample 1 is mounted. So the transit time was around 5 seconds for that mount. And the end effector does not have to dry in between samples, especially during screening. It just goes back into the Dewar and hangs out and stays cold until you need it again. The next part of the procedure is the auto centering of the crystal or the mount. So the crystal centering camera on the instrument is opened by CrysAlisPro, and the IGH is driven around until we find evidence of the mount on the camera. CrysAlisPro is using an edge detection algorithm to find the mount, and then it will use a few additional steps to try to locate the crystal within this nylon loop. Default centering settings take about 1 minute to center a crystal. In this case, you can see that the crystal, the lysozyme crystal, is a little bigger than 100 microns based on the red circle, which is a 100 micron circle. And when the algorithm is finished, CrysAlisPro will close the crystal viewing camera and move the goniometer into position to collect the diffraction images. There we go, it's finished. That took about 1 minute and 9 seconds. The goniometer is getting set up. You can see the detector, which in this case is the Rigaku Hypix Arc 150 degrees. The Arc 150 is a 3-module hybrid photon counting detector that's curved and gives you excellent coverage of reciprocal space. There's the diffraction data for lysozyme. Excellent spots, going out to about 1.39 angstroms. On the right-hand side of the CrysAlis interface, you can see that it's properly indexed. We just have a few ice rings in the data. I'm not surprised by that, given how quickly I was freezing down the lysozyme crystals to prepare for this demonstration. Now the system will go into an exchange operation, which is essentially a dismount step immediately followed by a mount step. So we've got to dismount crystal number 1 and put it back in its position in puck number 1, and then immediately go and grab crystal number 2 and mount that on the IGH. So sample 1 is now dismounted, put back in the Dewar. The transit time was about 5 seconds. And then the robot will go get crystal number 2 and mount that on the goniometer head. And crystal number 2 is mounted. For the rest of this video, we're going to speed things up by a factor of 3. I'm just going to show you the auto centering of sample number 2 and the diffraction images, and then we're going to cut ahead to sample 16, the last sample in the puck, see those diffraction images and the final steps of the robot, doing a last dismount of the sample and placing the Dewar plug back on the lid, and then doing the final dry of the end effector. For the last lysozyme crystal, sample 16, the only thing I want to point out is that the timer is very close to 57 minutes for screening all 16 crystals. And with the last few steps of the robot, it will take us just up to the hour. So we can screen 16 samples from a single Unipuck with the Actor 2 system in just about an hour. So how do we do in terms of results? So I actually have a local copy of the results viewer right here. And so CrysAlisPro has a really nice results viewer that allows you to take a look at what you've done using the Actor 2 system. So on the screen here, you can see at the top, I have a table showing me different columns, different values of data. Underneath, there are pictures of crystals and screening information. So if I have something selected in the top, like the first crystal is selected, these are the images from that first crystal screening. So I can double click on this and see the image from the screening, or from the auto centering. The information when it screened the diffraction images is here. So the peak hunting fit a unit cell 50% indexed. It's a tetragonal primitive cell. It's proper for lysozyme. And the images are shown here at right. And if I double click on the images, it opens the images up for inspection. So I can go down the list here. So this first one looks like this, and this is the second one. And I'm just going to use the arrow keys, the third, the fourth. So the fourth one is a nice one that's got no ice in it. Fifth, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So some of them had ice rings, some of them did not. But I talked to you earlier about the rank score. So you can see there is a column here for the rank score. So this numerical value is the scoring system. It's supposed to tell me which crystal was the best according to the scoring criteria. So you can see 510 appears to be the one that scored the highest. If I double click on this, it will open the experiment in an offline processing instance of CrysAlisPro. So then I can just examine this like I would examine any other screening experiment. I can mouse through the images. I can try to play with the indexing and refine this indexing. And any of the ones that I like here, I can choose to go on in the software and perform another job by checking them, the ones that I like. And then I can do an operation with a checked value, which is I can rerun the screening and then do a data collection on these, or I could manually use the Actor 2 to mount any one of these samples and then perform a data collection. So the results viewer is pretty, it's pretty comprehensive, and there's a lot of columns here that you can use. You can add columns, take away columns, depending on what information you want to see. And then you can also export this information out to something you can, in another format, a CSV file that you can take off to your computer. The last thing I wanted to show you is related to Actor 2 recovery. So whenever you're using a robotic system like this, it's complex, and there will be occasions where you have some sort of robot error. And typically what the Actor robot does when there's an error is it stops wherever the error is, and the robot just stops and waits for a human to come in and recover the robot. Now on our Actor 1 system, recovery of the robot was complicated via the teaching pendant. You had to know how to hold the pendant properly, which buttons to press, and you were manually moving the robot around like a toy robot, like where you have controls with your fingertips. And so the new Actor 2 robot has a much easier way to recover it, and that's what I'd like to show you right now. So the robot here is stuck in the Dewar because it had some sort of collision. So I come in and I pick up the new touchscreen teaching pendant, and I just press a few buttons. I put it in local control, and then I turn on the free drive operation. And once it's in the free drive mode, I can just grab the robot and move the robot to where I want it to be. So I pull the robot out of the Dewar, I replace the Dewar plug, and since the robot is taught a position just above the Dewar plug, I'm manually bringing the robot back to that known spot, and then I will put the robot back into the remote control mode, and then use the software here. This is the cameraman interface. I'll reconnect it, and I'll just tell the robot to go to the wait position. There's a little warning about making sure the goniometer is clear. As soon as I acknowledge that, the robot is recovered. So that's real easy and super fantastic. Let's go to the next thing. So that's it. That's all I have for you as far as the Actor 2 goes. I'd be happy to take any questions that you have.
All right, thank you very much, Mark. That was a very nice webinar. So we don't have any questions yet. While we're waiting, I just wanted to ask you, so how long have you been working with the actor yourself now?
It's been as long as I've been with Rigaku, so just over 11 years.
And have you used it for much small molecule work at all?
Just in a few tests, a few tests. It works great for small molecules. It works cold, or you can use it dry. If you don't need the samples to be cold, you can use it. You don't have to fill the Dewar up, and you can change the times in the software so that you're not waiting for these soaks to complete, and then it'll go really fast.
Yeah, so when you were showing the results viewer, there was some shading, color shading on the background. So the experiment list, you had green shading behind some of the experiments. Could you elaborate on what that's about?
So whichever operation you've asked the robot to do, in this case, I did a screen job. If it completes successfully, the background of that row in the table will be green. If there is some sort of error that happens while you were screening that sample, you'll get a different color highlight along the back of that row. And one of the columns that you can have in the results viewer is a failure or an error message column. So if there was some sort of error that happened for that sample, not only would the row be colored, but you would have some message in that column that tells you what error happened. For example, one error that can happen is it couldn't find the sample during auto centering. So it just moves on if it can't find the sample.
Great, thank you. Okay, we still don't have any questions, quite a shy audience today, I think. So I guess we're almost at the half hour anyway. So with that, I guess we'll wrap up and say thank you very much for the nice presentation, Mark. And we'll see you all for the next topic webinar, which we will be announcing reasonably soon. Thank you very much.
Thank you.